Good afternoon, Advanced Algebra students. I am super happy to see you again. We are doing our last lesson and our little detour into the Algebra 1 book for Chapter 7 on factoring. We're doing our last factoring lesson today, and then our next lesson we're going to jump back into the Algebra 2 book in Chapter 2 to finish that off now that we know a little bit more about factoring. So today, so far we've talked about GCF. We've talked about factoring x squared plus bx plus c. We've talked about factoring ax squared plus bx plus c. Today we're going to talk about two special cases. And actually it's technically maybe three, but one of them, there's kind of two that go together. So the first two kind that we're talking about is when we have what's called a perfect square trinomial. A perfect square trinomial is when we have a binomial squared. So for instance, a plus b times a plus b, or a minus b times a minus b. If we FOIL these expressions out, we can see that we get the same format each time, where we have an a squared in the beginning, a b squared in the end, and the middle term is just 2 times a times b. So if we want to, we can use that pattern to help us factor when we see trinomials in that format. So let me give you a specific example so you can see what I mean. Let's say we have x squared plus 14x plus 49. What I can do is notice that this is x squared here, and this is 7 squared on the other end. And then this middle term is simply 2 times x times 7, or 14x. Because that's true, I know that my a is x and my b is 7, so I can just write this as x plus 7 times x plus 7. I can do a similar thing. Let's do another example with another perfect square trinomial. Let's say I have 9x squared minus 30x plus 25. In this case, my first term is 3x squared, and my last term is 5 squared. So my a is 3x, and my b is 5. And we can see that this is a perfect square trinomial because my middle term is, again, 2 times a times b. 2 times 3x times 5 would indeed be 30x. Because of this minus sign here, I know that I need to write this as 3x minus 5 times 3x minus 5. Now, I don't have to use this shortcut if I don't want to, because I can take the 9 times 25, like we talked about last time, write this as 4 terms, split it into 2 groups, and then regroup. That would be totally acceptable to use the method from last time to do this. However, some students do prefer to have this shortcut. Let me give you an example of a little bit of a word problem. It's not a very long word problem, but a little bit of a challenge question. It says, identify the value of c that would make the trinomial factorable using the perfect square pattern. So let's call this example 3 and say we had x squared plus 12x plus c. What they're essentially asking is, what would this last term need to be to make this be a perfect square trinomial? Well, I know that the first term would have to be a squared, and c has to be something squared, so that when I took 12x, I would end up getting 2 times a times b. Now my a is x, so I know that 12x has to be 2 times x times b. And if I divide both sides by 2x, I can see that b is 6. So I know that this would have to be 6 squared, or 36. All right, so those are the only 3 examples that have to do with perfect square trinomials. Now, I want to show you another shortcut, and this one is essential to know. The first one's kind of like, if you prefer the shortcut, use it. But the second type of problem is one that you really do have to memorize, and this is called a difference of perfect squares. We call it DOPS for short. difference of perfect squares. And so in this particular case, what we're doing is taking a plus b times a minus b. If we were to FOIL that out, we would have a squared minus ab plus b squared, minus b squared, which would simplify down to a squared minus b squared. So this is really important to know that. Let's do an example here. Let's look at x squared minus 9. I know that this is x squared minus 3 squared, so my a is x and my b is 3, which means I can write this as a plus b, which would be x plus 3, times a minus b, or x minus 3. All right, let's do example, let's call this example 4, so let's do example 5. Let's say we have 4x squared minus 81. 4x squared is simply 2x quantity squared, and 81 is 9 squared. So I know I can write this as 2x plus 9 times 2x minus 9. Okay, so that's pretty much the gist of what you need to know in terms of the two basic special occasions, perfect square trinomials and difference of perfect squares. I do want to reiterate that with both of these problems, you always want to do a GCF first if you can. So for example, let's look at this one, example number 6, I believe. 3x cubed y minus 12xy cubed. Anytime we're factoring, we do want to look for a GCF, and if we can do a GCF, we want to do that first. So we can take out a 3 from both terms, an x from both terms, and a y from both terms. When we do, we have x squared minus 4y squared left. Now, we have factored this perfectly using GCF, but we're not done because this parenthesis here represents a difference of perfect squares. This is x squared for my first term and 2y squared for my second term. So the final answer to this problem would be 3xy times x plus 2y times x minus 2y. That would be the fully factored form. Okay, I would like to do example number 7, a word problem with you, and then that will be it for today's notes. So let's go ahead and look at example number 7. I'm going to read the problem, and as always, you don't have to write down every word, just what I put on the board. It says, the area of a playground is 16x squared minus 25y squared square feet. So let's write that down. 16x squared minus 25y squared. Okay. Factor to find the possible dimensions of the playground. What value would you need to subtract from the longer side and add to the shorter side for the playground to be a square? Okay, so let's go ahead and look at this. We can see that the first term is 4x squared, and the second term is 5y squared. And we can see then that this is a difference of perfect squares. So I can factor this as 4x plus 5y times 4x minus 5y. So this would give us the dimensions of the playground. Now to make a square, what we would have to do is add 5y to the smaller one. So add 5y here, and then subtract 5y from that one. And then we would have a perfect square. All right, thank you so much, guys. I look forward to seeing you in Zoom. Bye.